noiseless channels are very rare. I mean, it cannot be applied in your real-time data transmission. So noisy channels are most we see in our data transmission in day-to-day life. So let us see the protocols involved in your noisy channels. So the first among your noisy channel protocol will be your stop and wait ARQ. ARQ, which means automatic repeat request. So the concept of stop and wait is same as your noiseless stop and wait, but the thing added here is that you will have a time limit for each and every frame you send it to the receiver. So if the time has exceeded and the frames is not sent, the frames are being retransmitted by the sender, which means that the sender will keep the copy of the frame of whatever he is sending to the receiver. So until then the receiver doesn't receive the frame, the sender will know that the acknowledgement has not came yet, and it retransmit the frame to your receiver. So let us look into the design of stop and wait ARQ. So if you see here, these are all the same process. So here I have two terminologies. One is sequence number and next one is my acknowledgement number. So the sequence numbers will be in terms of your modulo to arithmetic. That is in terms of zeros and ones, which differentiates your each and every frame. So pointing here that SN, which means that next frame to be sent. So now I got to send this frame and I am sending this frame to my receiver. So on the acknowledgement, the receiver will tell that, so I have received my frame 0. So in the acknowledgement he sends that you send me the next frame 1, which will be your acknowledgement number. So you can see here that an extra event, that is timeout, of a timer is set for each frame that you send from your sender side. So this is a sender side algorithm for your stop and wait ARQ. So first my SN, which means my sequence number, that is 0. First the frame 0 should be sent first. Next I am setting my condition can send is equal to true. Next the data keeps processing until it receives from my network layer. The same story, it waits for the event, and if the event request to send and can send. So upon satisfying these two conditions, what my data link layer does, it gets the data, it makes the frame. So in that frame the sequence number is also added. So it stores the frame, because I have told you already that the copy of the frame is needed if the frame doesn't reach the sender, I mean the receiver, properly. Next it sends the frame. After sending the frame, it starts the timer. After starting the timer, the sequence number is incremented by 1, that is the next frame will get the next sequence, and my can send will be false until I receive my acknowledgement. So next I will wait for the event. What event? That is the acknowledgement frame. If my arrival notification, that is the acknowledgement has received, so this receive frame should come with the acknowledgement number. So if my received frame is not corrupted as well as my acknowledgement number is equal to my sequence number, so if these both matches, so now the acknowledgement number is coming 1, and here the next sequence number will be 1 to be sent. So I will stop the timer and I will purge frame, which means that I don't want the copy of my frame because I have received my acknowledgement. I will simply discard the copy of the frame. Next, I will set the condition can send is equal to true, that is allowing my next frame to be sent to the receiver. So if at all the timer is out before the acknowledgement has received, so again the timer will be started and that particular frame, that is Sn-1, the previous frame will be resent. So this is a sender side algorithm for your stop and wait ARQ. So if you look into the receiver side algorithm for stop and wait ARQ, here it receives the frame 0. So whatever it is, the starting we send frame 0 and this receiver also expects the frame to be 0. So next the true condition, next it waits for that event. So after getting my arrival notification, it will receive the frame. So it will check for the conditions. If the frame is corrupted, it will not respond, it will just sleep. And then if the sequence number is equal to the Rn, which means that the receiver's expectation, if this data frame is validated, it extracts the data from that particular frame, it delivers the frame and next it sets the next frame, that is the 0 has arrived now and the next frame to arrive is 1, so that the Rn will be set to 1. So send frame Rn. So Rn here will be 1. So this will send the frame, the acknowledgement. So this is what happens in your receiver side. So this is a flow diagram for your stop and wait ARQ. My first frame is 0. Yes, I set the timer, that is it has started and this frame 0 has arrived here and the receiver will acknowledge that to send the next frame. The acknowledgement here is nothing in the sense, the receiver tells to send the next frame of your current frame. So the next frame here will be 1. So the acknowledgement has received and the timer stops. So whatever copy it has, it will just discard. So next I am sending 1, the timer starts and upon transmission my frame 1 has been lost. So the timer will expire so that the sender will know that the frame is not yet reached my receiver. So again I am starting my timer, that is I am restarting my timer, that is frame 1 is resent here. So there it is received properly and the receiver tells the next frame, which is your acknowledgement 0. It acknowledges 0, which means it tells send me the next frame 0. So here the acknowledgement comes. So next 0 will go. Here I am setting the timer and I am starting it. So frame 0 goes. Yes, it reaches the receiver successfully. Upon coming back, the acknowledgement will be lost. So what happens? The timer here will expires. So and then it restarts. So the sender has to again send this 0 frame again, that is it is resent and there it has arrived. And finally next 1 has to be acknowledgement and it reaches the sender. So this is how your stop and wait ARQ processes. So in the line of your noisy channel protocol, the next one will be your go back N ARQ. So here if you see that we have a concept called as sliding window. So here we have terminologies of sequence number. So this sequence number, it will be in terms of 2 power m. That is, if m is equal to, say for example 4, your sequence number will be of 16. So if you look here, so this is my send window for go back in ARQ. So this is how your frame in this algorithm. So in the previous protocol, we have seen the sequence number to be in terms of 0, 1, 0, 1. So here you could see the sequence number from 0 to 14 or 15. So here the window size will be 2m minus 1. A simple concept, a window is used in this protocol. If you see in this diagram, so I have a sequence number from 0 to 15. So here the darkened portion tells you that the frames are sent to the receiver, yes, but it is still to be acknowledged, or it is still to get the status of your acknowledgement. So next, if you see that these frames can be sent, but it has not received from the upper layer, which means that the data covers only 0 to 6 positions and my remaining data is yet to come from my network layer. So here you have a term SF, that is send window first outstanding frame. So this is the first frame you need to send. So this one is the next frame you need to send. So if you see here, we have sent the multiple frames to my receiver. So in the previous cases, we have sent 1 by 1 frames. So here as a whole, I will send all the frames to my receiver. So what happens in the receiver side is that, so now if you see that my 0, 1, 2 portions are undarkened, which means that in the receiver side, it has given the acknowledgement for 0, 1, 2. So upon giving the acknowledgement, you could see that this window size has been slided 3 positions away. So this is the concept of your sliding window. So in the receiver side, he gives a valid acknowledgement for whatever frames he has received. That is, the frames should be in order of your sequence number. So if at all it is not in the order, the receiver will simply discard the frames. Now you could see the receiver window, that is, until here the receiver has acknowledged and next he is expecting the frame 3. And this frame 3 has given the acknowledgement that next what happens, the frame 3 has been received and then it has moved only 1 position, which means that your receiver window will slide only 1 position for the valid number of frames he has received. So this is a design of your go back in ARQ. So the same story, this is the entire frame I have. So these many frames I am sending, which means that I am able to send multiple frames, but in my receiver he will process the frame 1 by 1 only. So this is the concept of your design of go back in ARQ. So the window size is a main concept here. I have already told that the sender window size 2 power m minus 1, which is nothing but the sequence number. The window size is nothing but a package of your sequence number, and in the receiver side he can slide only 1 slot. So now we will make a comparison between the window size. So keeping my window size to be less than 2 power m and is equal to 2 power m. So consider here m, I am taking it to be 2. So I should have a 4 size sequence number. So now it is less than 2 power m, which means that I am taking it to be 3. I am setting my window size which is less than 4, that is 3. So if you see here that the window size 0, 1, 2. So first I am sending my frame 0. Yes. So the receiver, it processes, and upon receiving the acknowledgement is lost. Next, the frame 1 is sent. Here the receiver processes and the acknowledgement is again lost, and thereafter he sends 2 and he processes the frame 2 also, but the acknowledgement is lost. So for all the 3 frames the acknowledgement has been lost. So here the timer is set for the entire sequence of what we have set. So now coming to the point, after receiving the frame 2, the receiver will expect the frame 3 because my actual size of the window will be 4, which takes 3 also into my account. So now what happens, without considering this 3, the frame 0 is sent. So what happens that we know that the window size is 4 actually, but I have set my window size to be 3. So the receiver will discard the frame 0 that has sent by the receiver, which means that the receiver will know that this frame is yet to receive from the sender. This is in case of window size less than 2 power m. So next, coming to 2 power m only, that is when keeping the window size to be 4. So the same story, frame 0, 1, 2, 3. So all the frames are sent and it is processed in the receiver side, but the acknowledgement for each and every frame is lost. Cool. Then the next frame will be 0. Obviously my next frame will be 0, but in this case the receiver will accept. Why? Because my window size is over and my sequence of my next window size has been started, which means that my next the next cycle of my frame has been started. So coming here, this will be accepted by the receiver, but what happens for these frames, I have not yet received my acknowledgement. So on comparing these both, it is better to have my window size which is less than frame, which is less than my window size. So instead of accepting the wrong data, I can correctly discard the whatever data I have received. So this is the main concept of why your window size should be less than 2 power m. So it will be better understood with the help of a flow diagram. As I mentioned already, the timer will be set for the entire sequence. That is, first I am sending my frame 0. Yes, it has received and one acknowledgement comes back. When the acknowledgement comes, the window slides, and the next one is the frame 1. Yes, the frame 1 has gone to the receiver, the receiver has processed, and next it acknowledges the second frame, which in turn has lost. So here if you see that the windows doesn't slides. So next the frame 2 will be sent and the frame 3 will be sent. So when I get the acknowledgement for this frame 2, that is acknowledgement 3, this acknowledgement as a whole tells that acknowledgement 2. So whenever the lost acknowledgement is followed by the acknowledgement of the next frame, it carries the acknowledgement of the previous frame as well. So on receiving here, you can see that the second portion is acknowledged and the window has moved. So whenever the acknowledgement is lost and next acknowledgement arrives, so this acknowledgement cumulatively tells that the 2 has also been arrived. So next the frame 3, and it also gets the acknowledgement 4. So this is how your window slides in the sender side, but you could see that the receiver processes a frame by frame only. So next one will be the last one will be your selective repeat request. So here the concept is same as your go back in ARQ, but the main difference will be your window size. Here the window size will be half of the entire sequence number. So there we had a sequence number, one full sequence number. So here I will have only 1/2 as my window size in my entire sequence number. So next, all these terminologies like SF, SN, the size, all are common. So now the frames, these are sent and these are yet to be sent, and these are which cannot be sent, which means that only after receiving this my windows slides. So this is the major concept of your send window, that is 2 power n by 2 window size. So in the receiver window, the receiver, it gets all the frames from the sender, and you could see this dark thing. So this means that these frames have arrived in a out of order, which means that the sequence number is not proper for all these frames. So what it does, it waits for your neighbor frame to arrive, and upon the neighbor frame coming, so it takes the correct sequence number and thereafter it sends the acknowledgement. So this is the concept of your receive window. So you could see the same process. So everything, this is the same. So here I have a sequence number. Here in the receiver side, he acknowledges properly with the acknowledgement number for the correctly arrived frame, or he sends the negative acknowledgement, NAC number, which means that the negative acknowledgement for the particular frame which has not received in an order, I mean the sequence of the order. So here also we do a window size comparison, which is 2 power m minus 1. So as I have mentioned already that the window size of both the sender and receiver should be half of your sequence number. You could see here. Yes. So for the same case, the acknowledgement has been lost. Next, the frame 0 is sent to the receiver, but it is not actually 0 because my frame size will be 2 power m minus 1, that is 2 power 2, that is 4, 4 minus 1 is 3. So in the third position I have 2, the 2 is the proper frame to be sent. So this frame 0 is discarded at my receiver side. So my frame 0, 1, 2 has been, the acknowledgement for all these frames are lost. So the next frame will be 3. So instead of sending 3, the frame 0 is sent, but the receiver knows that 3 has to be sent. What happens? So it will accept the frame. Here my window size is less than 2 power m. So the same scenario, this 3 has came to an end. So the acknowledgement has not yet received from the sender. The frame 0 is next sent, but it will get accepted. Why? Because my window size is actually 3 only. So frame 0 tells that the start of the next cycle. So instead of accepting the errored frame, we can correctly discard the frame that has been received. So the proper thing is that the window size should always be 2 power m minus 1. So this is a flow diagram for your the selective ARQ. So here the frame 0 has arrived, acknowledgement has been got. So the window slides. Now frame 1 is lost, and then the frame 2 is sent, and then the frame 3 is also sent. So the receiver gives a negative acknowledgement of 1, which means that the frame 2 has received, but he did not receive the frame 1. So he gives a negative acknowledgement that frame 1 has not yet arrived to the sender. So what he does, he sends the frame again, he resends the frame, and upon receiving the frame as a whole, I receive an acknowledgement 4, which means that I have received the frame 1, 2 as well as 3. This acknowledgement 4 gives a cumulative acknowledgement for all these frames. So this is about your framing concept in your data link layer. So in next class, let us look into the next thing called media access control, which takes up the medium of how to communicate the data. Thank you.